Welcome to my channel P Concepts CHM. This is the fifth part of conduction in semiconductors, where we will see about the drift current and the diffusion current. Drift current. For T greater than 0 degree Kelvin, no electric field is applied. So due to the thermal energy, carriers move through the crystal. So there is no net transfer of charge, since the number of charges moving in one direction balances the number of charges moving in any other direction. Now if a field is applied, each carrier experiences a force attracting it to one end of the material. The electrons will move towards a positive potential and the holes will be moving towards a negative potential. So the net movement in the charge is called as drift. This drift is superimposed on the random thermal movement, resulting in a current flow. Electric current density is given as J is equal to Ne into V suffix D, equation 1, where V suffix D is the drift velocity. The Ohm's law can be given as J is equal to sigma E, where sigma is equal to Ne square tau by M, which we had derived in electrical properties of metals. So this can be also written as J by E, equation 2. Now the drift velocity V suffix D is proportional to E, which can be written as Vd is equal to mu into E, equation 3, where mu is the mobility of the carriers. Substituting equation 3 in 1, we get J is equal to Ne into mu into E, equation 4. Current density due to the electron drift can be written as J suffix N suffix drift is equal to N into mu suffix N into E. So equation 4 we are writing in this form. And current density due to hole drift can be written as J suffix P drift is equal to P into mu suffix P into E. Substituting equation 4 in 2, we get sigma is equal to J by E is equal to Ne mu, and rho is equal to 1 by sigma. This is resistivity, that will be equal to 1 by Ne mu. So the total drift current we will write down now. J is equal to Ne mu Ne plus Pe mu suffix P into E. And sigma can be written from this equation as Ne mu suffix N plus Pe into mu suffix P. Now for an intrinsic semiconductor, N is equal to P, which can be taken as N suffix I. So we can write down this equation as sigma is equal to Ni into E into mu suffix N plus mu suffix P. Diffusion current. Diffusion current is due to the non-uniform concentration of carriers at some places of the crystal. In the absence of electric field at equilibrium, free carrier concentration is uniform due to the combination of random thermal motion of electrons and the repulsive force between them. So a non-uniform distribution is created. That is, excess carriers are introduced in the semiconductor. This can be done, that is, by this carrier generation can be done by heating, by incident radiation, by injecting carriers into the semiconductor via a surface contact. Ignoring the process of recombination, the excess carriers move from high density region to low density region, tending to produce a uniform distribution. This net transport of charges is called diffusion. Suppose the concentration N varies with distance x. So the concentration gradient will be established, which can be written as minus delta N upon delta x. The negative sign indicates the electrons move in the direction of the negative gradient. Rate of flow across unit area can be given as minus d suffix n into delta N upon delta x, where dN is the diffusion coefficient for electrons. Electron diffusion current density is given as Jn diffusion is equal to minus E into rate of flow across unit area. So you can write down this as E into dN into delta N upon delta x. If excess hole concentration is created in some region, hole diffusion takes place in the same direction. That is, holes move from high density to low density region. Therefore, rate of flow across unit area can be written as minus dP into delta P upon delta x. So same way we can write down Jp diffusion is equal to plus E into rate of flow across unit area. That is minus E into dP into delta P upon delta x. Total current density when the field E is applied and if a concentration gradient in the x direction exists, it will be the sum of the drift current and the diffusion current. So Jn is equal to Ne mu n into E plus Dn E into delta N by delta x. So this is the drift current, this is the diffusion current. And in case of holes, Jp is equal to Pe mu P into E minus dP into E into delta P upon delta x. So this is the drift and this is the diffusion current. Thank you for watching this video.